Pleasure to meet everyone, although virtually. What I'd like to be talking about today is a little bit along the lines of how do we authenticate public data. And this is something that has been in my mind ever since I started to work with smart contracts before even we had founded Eris Industries, which, as Dennis said, is a smart contracts and blockchain company. A little bit of background on myself. Actually, I don't need to because Dennis already shared it. So what I would like to talk about first is a small experience that I had a few years ago. When I was in Somaliland, I was in a meeting with the newly appointed Chief Justice of Somaliland, and he had been in, I don't know, he had been appointed maybe about a month at this time. And we were sitting together in the evening talking about some of the challenges that the judiciary faced. And one of the challenges that he identified was the fact that most of the judges, particularly even the Supreme Court, did not have a full copy of all of the laws which had been passed by Parliament, by the Somaliland Parliament. And I said to him that was a tragic situation, but we would be happy to help. As a law firm, we had assembled most of, if not all of the laws in PDF format so that we could share them around within our young lawyers. And we said we would be happy to print those out for him. To which he said, how on earth do I know that you didn't change them before you printed them out? Which is an extremely fair and prescient question, which sort of leads me to today's topic, which is how do we actually authenticate that government or public information has been published and is actually what was published without doing a textual analysis that compares what we're looking at, which frankly is exceedingly hard, particularly when you're talking about what my passion is, which is in legal documentation. As I hope I am speaking to the choir or preaching to the choir, I mean to say, PDFs are horrible. The idea that many government agencies have around the world that PDFs are somehow an unchangeable file format is quite tragic, frankly, because PDFs are a very changeable file format. They're just files, just like anything else. And a lot of government agencies and public agencies feel that the way to publish authenticated data is just to publish a PDF, and that's not exactly the way forward. Now, XML documents are better for machine readability, but they still present a challenge for authentication. And what we're talking about with authentication is how do we tell that this information that I'm looking at is what was actually the information. Now we get to kind of one of the first sort of primitives of cryptographic software, which is the idea that we can take a piece of software, a file, let me say, and we can sign it using cryptographic methods. And this is what's called a digital signing algorithm. And the reason that many government agencies feel that PDFs are an immutable file format is because Adobe, the company, has offered an add-on to their Acrobat software, which allows folks to digitally sign PDFs. And if a government agency has digitally signed a PDF, then it could be immutable. But what happens fundamentally when we digitally sign something is that we're wrapping the whole file around a signature, and that signature can only have been created by a computer that has both a private key and a public key available to it. And having both of those keys together is what allows the computer to create the digital signature, which wraps itself around the existing file. And that's what we can then publish. We can publish what's called a fingerprint, which is a short string that can tell someone that this file is what. Sorry, let me back up. When you sign a file, what you get out of it is a couple of things. You get the signed file itself, and then you also get a shorter string, which can be used as what's called the fingerprint. So if someone downloads a file from the internet, and routinely when people install software, they do this. Behind the scenes, usually, computers will compare the fingerprint of the file that they downloaded from the internet to some sort of a out-of-band publication of what that fingerprint was. In other words, the publisher of the file says on their website or whatever, here is the fingerprint of the file that you should be seeing. So then when someone downloads that file from the internet, then they can, on their own computer, they can take the fingerprint of that file, and then they can compare to what was published on the website to make sure that what they actually have on their computer matches what the publisher published. And this is called fingerprint analysis, and it's routinely done when you install software. Now, this is super helpful when we get to data. And I am not an expert on all data, but I do come from a legal background. And one of the things that could certainly benefit from a simple digital signing algorithm and fingerprinting mechanism is something like court decisions. These things are generally need to be authenticated as actually coming from the judge that published them, and they also don't really have to be linked into other things. Now, the second part of this is, what about information, particularly public information, which needs to be, which might change over time? Now, this information gets a little bit more challenging because at this point, you not only have the authenticity challenge, which a digital signing algorithm can facilitate, but you have an additional coordination problem. And this is where blockchains potentially could be brought to bear for the benefit of the public. Blockchains, for those that aren't totally familiar, are the database mechanism that sits behind Bitcoin. And what they fundamentally are is a distributed database which is built in such a way to heavily use digital signing algorithms, and out of the box is built to be to work on a peer-to-peer mechanism rather than on a master-slave relationship, which most databases traditionally do. And what that means fundamentally is that if you are the user of a blockchain, your computer will be talking to a whole range of other peer computers, and by consensus you will all be determining what the database looks like. In other words, what the transactions were, what the current state of play is. You will all be doing this via a consensus mechanism, and part of that consensus mechanism will be to fundamentally check all of the digital signing algorithm, all the digital signatures that have come along the way. Now, they're very useful tools for information which needs to be verified. They, out-of-the-box blockchains provide a very rich and rich fabric for verifying a range of information. So blockchains are very good at coordinating information. As I said before, they have a sophisticated digital signing algorithm and also a peer-to-peer information sharing module. And blockchains have a real strong potential of being quite helpful when you're looking at data that might change over time. Whereas with digital signing algorithms, that might be sufficient for when you're talking about court decisions, let me say. If you're talking about a corpus of laws, which might actually change over time, or a set of regulations, which also might change over time, then blockchains will be more helpful than only a digital signing algorithm, because with a blockchain, you have an ability to coordinate basically what is current. And by being able to coordinate what is current, uh, along with the digital signing algorithm part of that comes with a blockchain, then you can gain two things. You can overcome both the authentication problem, and you can also overcome the coordination problem as to what is current. And that was my very, very brief introduction. Dennis asked me to talk for about 10 or 15 minutes and then to answer questions. So I'd like to, at this point, answer any questions that folks might have. I can't really see you, but I can hear just fine.
So guys, the floor is open for questions. Just Casey will share the picture of the theater. There is about 20 people. Yeah. So guys, do you have questions? Who has questions?
And what happens? It's about authenticity, right?
Authenticity, yes. I have. Yeah.
So. What happens if you get into a lawsuit? Maybe it's a bit extreme, but and there are documents made about you, about say how you download it. How can you say how can you know it's authenticated? How do you know that it's real, that it's not been altered?
I'm not sure that I understand the question. Like at this point, like Casey is talking about authenticity of the.
Speak to the microphone.
Sorry.
Can you speak to the microphone?
Hello, can you hear me? Yeah. The microphone, Eugene, can you look like there is no technician? So we've been trying to make it. You cannot hear me at the back, can you?
Hardly.
Hardly. Okay, sorry about this. Yeah, the microphone seems to be dead, but all right. That's why we were asking for people to move forward. Yeah, the question is how
should government use blockchain?
How the government should use blockchain. Yeah, how the government should use blockchain to authenticate the information which they release. Is it your question? Yeah.
Yeah, it would. It's hard to say in the abstract because it would very much depend on the type of information which one was talking about. But a very simple way in which one could imagine someone using a blockchain is a similar site to what is called proofofexistence.com, which is a very, very simple website. But the idea is that you can upload a document to proofofexistence.com, and what it will do behind the scenes, the server, it will sign the document on your behalf. You wouldn't necessarily want to do that. You would want to have the government agents actually sign, and then it will send a transaction to, in their case, the Bitcoin blockchain, which will then have the hash of the signed file in it. So then forevermore, because Bitcoin's blockchain will probably never go anywhere, I mean, in the sense that it will always be around, then that data will always exist. At least the hash of that file will always exist. The fingerprint, when I say hash, I mean fingerprint. And that's one way in which governments could potentially increase the authenticity challenges that they have. If they have publicly said that when files have been signed by this public key, that public key is until we revoke it, held by this court or this government agency or this city councilor or whatever the case might be in whatever the government system one was talking about.
Yep, thank you. Yes?
If this blockchain, I call it like that, serves authenticates things, how is authentication checked? So I have something, I want to check if it's authentic on the basis of the blockchain. How do I do that?
How the blockchain is going to authenticate?
Given that it's like it serves to authenticate some information.
Right.
So there's the contract signed using the blockchain.
Yeah.
This is possible. How is that contract checked? So another person says that no, it didn't happen.
By the fingerprint of this contract.
How does it do it?
Well, the question is quite how the fingerprint of the contract which is created, let's suppose, going to be authenticated itself. Is it correct?
The fingerprint is authenticated?
Yes, it says.
Yes.
Okay. So there's two levels to this question. The blockchain will have no idea what that fingerprint relates to. In other words, when you're talking about a blockchain, it has a real strong capacity to be able to verify what its data is, and it has zero capacity to be able to certify the truthiness of that data. So in other words, the blockchain is useful as a coordination mechanism of what the data is. Where it is unuseful to folks is as a mechanism to check that the data is true. Now, there are workarounds there, one of which is that one could say every transaction that has been signed by this particular key has come from this particular government body because they have publicly announced that that public key is their public key. And so then you would have an ability to know that every transaction that you can see that was from that particular key came from that particular office. Then you would also have an ability to verify that the fingerprint which was put into the blockchain was properly signed. In other words, there was not a fake signature. Someone did not fake the digital signing algorithm. But what you will not have a capacity to do is to verify that a specific fingerprint relates to a specific file without actually having that file, and blockchains generally won't be used to store the actual data. In general, you would probably be using a blockchain more effectively if you simply used it as a coordination mechanism to say that this particular fingerprint was authentic because it came from this key which was linked in public to a particular government agency. Does that answer the question?
How I understand it is that there's a person can...
Can you come here? Can you come close? Yeah. Yes, can hear. Just so should I speak to the question to the mic? Yes, please.
Okay. Hello. So, given that how I understand it now, there's a person who has the
has some sort of identifier, and that person can sign something which produces another identifier. But how one can associate this identifier with anything? How is this digital signature significant at all? Apologies if I'm asking strange questions, but I'm new to the thing.
Yeah, no problem. Basically, you can know that particular, so you can verify that a file has been signed by a particular key. Now, what you still need to do is to link a public key to a particular government agency. And that is usually a simple publication mechanism. So, for example, many journalists, they publish what their public key is on their Twitter profile or on their author's page or some other location. And one reason they do that is for confidential informants to be able to send them encrypted email or whatnot. But another way in which that a similar paradigm could be used is to verify that a particular set of copy came from that particular journalist. And it would work the same way for government. So the government agency could publish that they had the public key, and because of the way that key pair cryptography works, it's perfectly fine to publish your public key as long as you keep your private key private. Then you need both of those in order to correctly sign something using a cryptographic digital signature algorithm. And so you can publish to the whole world what your public key is, and if someone were looking at a particular file that had been signed by you, along with a copy of your public key, those two sets of information, well, the public key along with the file can be used to verify that the signature of around that file was correct.
Okay, so does this pertain to anything else than a file, like a financial transaction? Can this be attached? Or, I don't know. Yeah, let's say that. What circumstances would a financial transaction be capable of being signed using this?
We're not really talking about financial transactions. We're just talking about raw information.
Yeah.
Okay. Thank you very much.
Thank you. Yeah, quick one, please.
Is the blockchain needed, or is it just the public key that's needed?
Is blockchain needed? Like the question is the blockchain needed or just public key is needed?
For most situations in an open data environment, I do not actually think that a blockchain is particularly useful. I think it can add a certain level of functionality, but really I think that most government information I think that just digitally signing government information is a great first step. If we have coordination problems down the road, then perhaps a blockchain might be useful. But because we're talking about government data, which usually should only really be coming from one source, you don't really have. One of the sweet spots for blockchains is where you have quite a few stakeholders involved in a system, and with government information systems you don't have the multiplicity of stakeholders, and so a blockchain may or may not be effective. It would really depend on the problem that one was trying to solve. If it was pure authenticity of information, then a blockchain doesn't really do anything more than just a digital signing algorithm would do, which is why I started with that, to be fair. But when you're talking about information that needs to stay current and and it gets updated over time, a blockchain may be an effective way to coordinate that information, particularly if you're talking about newer blockchains which are smart contract compatible vis-a-vis some older blockchain designs like Bitcoin, which is not really optimized to be able to do those things.
Thank you, Casey. Thank you. I think we need to move on to the next speaker, otherwise we'll be late. Sorry about this. Thank you very much for your time, and yeah, we'll be in touch. I'll send you a link connoisseur.
Cheers.
Bye bye.